In this video, we're going to see how to create a class diagram using Argo UML. Now, Argo UML is kind of funny. I have used Argo UML at the University of Cincinnati for a long time, probably going back to about 2004 or so. And it's one thing that has barely changed in that time. But that's nice, because it has stood the test of time. One thing that's funny though, Java Web Start, this used to be a really good way to run Java programs from the web. I've found that it's not supported as well as it used to be, so it might be easier just to download and install using this link, and then you get Argo running locally on your computer. Now, Argo can be used to create many of the UML diagrams like use case, sequence diagram, and many of the others that work very well with UML, but one of the more common that we think about is the class diagram, and so that's the default place where it starts. Now, what we'll typically do is we'll create a class diagram as part of our design effort, which usually happens when we're starting a project. That way we can make sure we understand what we're going to work on. I happen to have the advantage of a project that is essentially complete, so we can kind of do a bit of back and forth. And all projects should have some kind of class diagram, whether it happens at the end or at the beginning, but our preference is to do it at the beginning. So just a little footnote there that we're not always looking at something complete and creating a class diagram. Usually it's based on something we're about to create. But nonetheless, if we take a look at this project, we have several different layers of the application. We have the application and controller classes, which essentially make up the user interface and the controller that handles those response, and also the overhead of just starting the application itself. Then we have a data transfer object. Those are traditional nouns or traditional beings that we'd be used to in the Java programming language. A person, place, or thing. A car, for example. In other words, a vehicle, or a classroom, or a restaurant, or a hamburger. These are all things that would be DTO. Now we have also DAO, which is data access object. These are the classes that are handling any kind of interaction that we would have with a persistence mechanism. And then we have service, and those are essentially our business logic classes. So notice that they're cut up into a few different packages. A well-designed Java program will have a bunch of small Java classes that work together. So it's usually a good idea to organize them into packages where those packages describe what the kind of a theme for the classes that they contain. You can think of a package like a directory system. So kind of like folders, the com plain places folder, the com plain places DAO folder, the DTO folder, the service folder, so on and so forth. And these folders are easy to organize in Argo UML. These folders are these packages. So I can click on New Package, and at the very top I can title the package com.plantplaces, just like so. And I can also make the service package, so we'll say com.plantplaces.service. So that's kind of where we have our business logic and the like. Then we can have our DTO, so com.plantplaces.DTO. And then also our DAO. So we'll say com.plantplaces.dao. It's a good idea to think of things in this way, the way we can group them together, from the overhead of the application and the UI, to the business logic, to the data access, to the Java beans that are actually going to make our application. One thing I'll caution you about, sometimes I'll receive design documents and the only thing I see on the class diagram are the DTOs. In other words, a group might just say, oh, we're going to have a car, we're going to have coupons, and we're going to have a dealership. Don't limit yourself to just the noun classes. Think about all the other classes that are more action classes that are going to be doing things for your application. Okay, number 2, don't forget the importance of putting things into packages like so, because if not, your class diagram can quickly get hard to read and disorganized. And in my experience, the better organized the class diagram, the better the chance of success the group has, because everybody knows what they should be working on. Okay, let's start with the Plant Places application and Plant Places controller class. It's a class, so we're going to choose this new class thing here, which is essentially a 3-layer cake. So we'll say Plant places application, and then maybe give myself a little bit more room and grab another 3-layer cake here and drag it and plop them right in. Sometimes gets a little tricky, but there we go. Okay, and plant places controller. Okay, now let's take a look at the controller. Now the controller class has one attribute, but it's private, so we're not going to worry about that. But we can take a look at some of the methods or the operations, and we have a read JSON, add specimen, read silver, create index, several things like that that we would consider to be operations. So if we take a look, the operations go towards the bottom. You can click this little plus here, and we'll call this one read JSON, something like that. So that's an operation. I can go back and I can click on another option here, and I can say maybe create, or let's say index, just like so. So that draws up our starting page. So you see that methods are essentially operations, and those methods will go towards the bottom. Now, let's take a look at our DTO. If I look at plant DTO, well, we have a bunch of private attributes, and then we have a bunch of getters and setters. Now, we don't necessarily need to declare every single getter and setter. That would be a bit of work. But given that we understand what a DTO is essentially a noun class, a person, place, or thing. In this case, it's a plant. We know that these noun classes have attributes or adjectives that describe them. A user, a unique identifier, a genus, a species, a cultivar, and a common. So what we can do there is we can create a new class, we can put it in our DTO, and let's go ahead and call this one plant. And for plant, instead of worrying about the operations, let's give it attributes. So we do the plus here, and this one we're going to say GUID integer. Notice that we typically have the name of the attribute, a colon, and then its data type. So GUID integer, I hit the plus, and we can get another one. We can say genus string, just like so, and we can keep going. And again, given that this is we can say in this one species string, given that this is a DTO, it's a given that these are going to have getters and setters, so we don't necessarily need to call that out explicitly. Now, a plant is the scientific definition of a plant, but a specimen is a specific plant that we can touch. So for that, we have plant ID, specimen ID, latitude, longitude, and description. So once again, we can click like so, and we can say specimen. And inside of here, we can say plant ID, an integer. And then we can add another. We can say latitude. This could be a double, it could be a string, a float. I'm going to put this as a string just because of floating point arithmetic. So we'll go one more time, longitude, string, and then we'll just go ahead and say description, string, and one more time we will add the final one, which is specimen ID, integer. Close enough. Almost. Misspelled integer. There we go. Integer, just like so. Okay. Now we probably need to expand this guy a little bit, make sure that our DTO stays contained. It doesn't look like he's contained in there. There we go. Now he's all one unit. So our plant and our specimen. Okay, so notice the very first box is the name of the class. The second box are any attributes of that class. And the third box represents any operations. Now, these boxes are important because they help us to understand the difference between a class and an interface. If we take a look at our service, we'll see there's an interface called iSpecimenService. And an interface, up until Java 1.8, an interface by definition could only have method signatures. It cannot have attributes because attributes indicate state. So an interface is this guy with a little 2 layers instead of the 3 layers. The missing layer is the attributes because an interface cannot have attributes. So let's go ahead and grab this guy and we'll drop him over here. So how do we know that an interface is an interface in UML? First of all, only 2 boxes. Secondly, it has this kind of indication at the top that says interface. So on this interface, iSpecimenService, we see we have fetch by ID, save, and a couple of others. Let's just worry about a couple in the interest of time. We'll say fetch by ID, and then inside of this we'll say ID colon integer. So note that we're giving an indication of the parameter that's required here, and then we also have save. So let's go back up and let's do a plus here. Let's say save, and we'll say specimen colon specimen. So in this case, the data type that we're passing in is the DTO specimen. So you see we go from the primitive integer type here to the detailed specimen type here. Okay. So this is an interface, and we're going to call this interface, we'll call it iSpecimen service. Now, interfaces are very powerful when we have a group project because they allow us to set a contract of what we're working on. And that way, anyone who's dependent on this contract can work against the contract while the person who was working on the service might not be done with the actual implementation yet. That lets the user interface work against the contract while the specimen implementation is still being written. So let's draw a few things here. First of all, our plant places controller. This is going to have a uses relationship with this specimen interface. In other words, if you do something like search for a plant, it's going to come over here and do a fetch. Or if you create a new plant, it's going to come over here and do a save. So notice that this solid line going back and forth indicates a uses relationship between our user interface and our service. Now, under the service, I'm going to hit this dashed line. Take a look at this, and you note when I hit the dashed line, we get a new class here. And this new class is going to be specimen service stub. In other words, this class is just a hard-coded representation of what's in that interface. If we take a look at specimen service stub, you see it is hard-coding in some things about a specimen DTO. It's hard-coding in a fetch mechanism, so on and so forth, without actually using any kind of actual persistence. So first of all, we don't need this. That was a mistype on my part, so I'm going to take that away. But we don't need to replicate all of the methods that are in the interface because this is a class that implements the interface. And by definition, a class that implements an interface has to provide an implementation for all of the methods in those interface. So specimen service stub, if I were a service developer, the first thing I would do is I would create this interface collaboratively with my user interface counterparts so they know what they should be calling. Then I would create this stub, which just returns hard-coded predictable results, and that way the user interface can be built against the stub. Meanwhile, what am I doing? Well, I'm going to create the actual implementation. So I'm going to say specimen service impl, something like that. And that's what is actually going to do the work. So that is going to have a uses relationship with the items that are down in the DAO package. But we'll talk about that in just a moment. First of all, want to kind of just refresh on a few ways we know this is an interface. It has the interface marker up here. Naming convention is optional. Sometimes we'll begin an interface with an I, but that's not necessarily needed. It's only 2 boxes, not 3. And notice that anything that implements the interface has a dashed line with a solid, with an open arrow at the very top. Okay, now let's go down and take a look at our DAO. For our DAO, what do we have? We have a specimen DAO and a network DAO, and the specimen DAO uses the network DAO. So we should always have an interface to start things off. So we'll start with iSpecimen DAO. Okay, and then we know that we can have that implemented by a specimen DAO class. And then the specimen DAO knows what a specimen is, but the network DAO is something that understands the low-level networking that has to happen to talk to something like an online data store. So let's do this. I'm going to move this over. I'm going to show a uses relationship between specimen DAO and network DAO. Now, between specimen service impl and specimen DAO, I'm also going to show a uses relationship. So note the solid line with no arrow going from the specimen service impl down to the DAO. Now, why from the impl and not the stub? Remember, the stub is just returning a hard-coded result that makes this interface work, where the implementation is actually doing the work. So the stub does not have a dependency on the DAO because its results are hard-coded, but the implementation does because it's actually going and getting some live data. So at this point, we have a class diagram that's well represented with a lot of relationships. You notice that a uses a relationship is allowed to span across different packages, although a lot of times we'll have classes and interfaces that are doing a similar task within the same package. So DTO, we talked about what those are. We talked about the different features here. Okay, one more thing I want to represent. I want to show how to represent. Let's take a look at our plant places controller. We see that doesn't extend anything. We take a look at plant places application. That doesn't extend anything either. Let's say just for fun, let's say that we wanted to subclass this controller into some kind of an admin component. Watch what happens when I click on this controller and I hit the down button here. Compare it to what happened when I press the down button here on an interface. When I click the down button here, it gives us a class, but notice it gives us this class with 3 boxes. And a little hard to see unless I draw it out a little bit, but a solid line with a capped arrow. So we'll call this one admin controller, something like that, if we want to make like a subclass controller. So a solid line with an open arrow indicates an is-a relationship. You might not have heard the word is-a before, but you've probably heard the word subclass before. In other words, admin controller is a subclass of plant places controller. We know this because it's a solid line with the open arrow. That indicates superclass by the triangle, subclass by the bottom of the arrow. Okay. We also know it's a subclass relationship because both of these have 3 components and there's not the interface indication above. So again, just a subtle thing, but dashed line indicates a class implements an interface. Solid line indicates a class extends from another class. The arrowhead indicates subclass extends from class or class implements interface. A solid line with no arrow indicates a uses a relationship, where an arrowhead indicates an is a relationship between subclass and superclass. There are a couple other arrowheads too. There's a solid diamond, which indicates composition, like a car is composed of a transmission, an engine, and 4 tires, things like that. So there are a few other permutations, but for our use, these are the big ones that we're going to see. Now, if I want to save my work, I simply choose Save Project As, and we can call this Plant Diary, UML diagram, Plant Diary, UML, something like that. This allows me to come back and edit this later. If I just want to put this in a design document, I can do File and then Export Graphics, and it will actually save this diagram as a PNG. And then that's something that, let's see, we'll say Plant Diary, class diagram. Then that's something that I can include into a design doc. So I hope this video has been useful, and I look forward to reading your comments. Thank you.